Okay, so hey, training points every day. George Scoble coming at you from the STEM Lab. The Hadron Collider, as it were, the Particle Accelerator, the A Mechanics universe, hyperverse, multiverse, whatever you want to call it. Okay, so kind of kicking around some stuff today. We got A-Book, and we got the Horseman Code. I'm gonna find the start of it. Alright, so take a look at these things. Alright. Okay, we can check that by knowing some of this basic principles of master sheets, master plays. Alright, if it helps, I like to talk about it in a few different ways. I like to talk about it like a map climbing problem or survival. Army survival problem, mountain terrain, go figure. Boulder climbing, rock facing, you got to work on your handholds, different skill levels, there's a spectrum to it. And okay, we got the mountain, we got boulder climbing, and a vaporizer, an X-ray gun. In chemistry they kind of use it to analyze the perspective, but you can use a general XY system for this if you know what you're looking at. You know, everywhere. Remember, this is more than just the sum of those parts. Be a G, break it down where you see it, so you can make it a master chart. This is the play. When this comes up, if rookies come down, the king has made laws into this Sun Tzu greatest matter of the nation, matter having mass and weight, that is very hard to calculate in terms of its motion position, given certain Schrodinger's, equations, Heisenberg's uncertainty. You know, really, what's the numbers here? And good grinders out there, they're gonna know what I'm talking about. Those old school G's out there, I know exactly what number he's talking about. And it's not just running mucking it while you're waiting. There's other things to do. So that's kind of like your frame. And a lot of times in particle science, you'll actually see some of them, they'll be like laid out, and you'll actually see like this wave function. And if you like the wave function, it's like on a topo map. Well, think about your topo map here as well, in the survival function. 0 is survival. By terms, survival is a little differently here. It's that same way of looking at that old school of looking at these numbers and so many different. Having that notion is like 1 and 0. You know, this is by terms a positive situation when it comes to doing a lot of stuff with it, but let's face it, somebody's looking at you like this right now, doing their thing. That's just the numbers, it's just physics, it's just free radiance around it, as much as they're wild and heavy, moving fast. So another cool one I wanted to get out here in the Arch Lab was something about G-force. Now this is a really cool one. When you're using the X-ray spectrum, and you got the intensity of that particle, or its motion, or it's really super high spiked right there, so I can generally determine that there's some stuff going on right there, right now, with that palette. It may not look done, but when I walk around this room in my G-suit, because I'm an astronaut, Rocket Man Murphy here, going 9G monster with this thing, right down to the stick. You're in the day and you're looking for points to line up, you're looking for the topo map on that thing to change for what high points are. Why would I have multiple choices? There's a lot of different ways to run that palette. Floor setups change things. A lot of things make that field very different in the general ground law Haven way, fifth dimensional calculations of something like that. And well, the idea is here, the point is to blend general relativity and quantum mechanics to find a way to make a globular state a smooth state. How do I describe something like a skill set in here to be very square, and how useful that could be when you square them all up with this? That's the point. A Mechanics is going to be your training tool. It gets everybody speaking the same language, and they all basically follow a code dynamics, a transposition, a substitution, a ciphering, a resistance, mechanically, electrical engineering, as much as electrical, whatever, the electrodynamic theorem, or quantum electrodynamics. Oh, there's a bunch of them out there. Each of them have kind of like a subset that's one away from each other while looking at Higgs structures. Or not Higgs structures, Feynman structures in the master field of how these particles, this photon interacts with this neutron. Well, they start in a geometric state, all A. They can jump right here. Now I can see several movements and one increment movements from each of these positions. And then I make the choice. Why is this one more beneficial based on gravity? And this works with hand on the road, ass going down, hand in the wheel, ass in the seat going down the road. You don't think about the G's you're under the load of. It's easy when you're rolling pallets like this. You actually have to physically work here. Hick, hick, hick. Well, you're pulling 6 G's on something like this. Some other places you don't notice it. But yeah, it's a uniform pressure, even though it feels very different in a lot of circumstances. It's just one click, 1 second. And that's the difference in a lot of these things. When you're G, you know they're all amechanical moves. I can do this one. I can do this one. Doesn't matter. It's just time that determines its mass and value after that point. And, you know, a lot of this is about space-time. A lot about is trying to figure out those terms. Give it a name. Give it a place. Why does this work with black holes? Well, this has the same principles as hairy black holes, or no hair black holes. Which is really, you only have its mass, its spin, okay? Its mass, its spin, which is basically, right now I'm looking at something that's taking up this much volume, essentially. And that's based by it's got to be fixed, so I'm putting a mechanic on it. This is time off for somebody else's guy. They're going off somewhere. It displaces a lot of things. I look at all those negatives and say, hey, they're positives in terms of, now that I know that calculation, bang, right on to the next one. And it's by frames. They're all A's and B's and grids out, but I'm kind of looking at some of the internal mass of that particle. There's black holes there too, be careful. In the internal mass of this structure, you know, we're kind of shooting it down an electron here, or a hadron collider. Whether it's charged and we're ready to go for that or not, it just happens sometimes. She lets one off. You got to be ready for it. So you got to know some of the numbers. All right, this geometry can be very different depending on the structure and how I'm looking at it, and therefore how to calculate it, analyze it correctly, to form it correctly in the logical progression of what's happening here, much like this code and how it's described. As you're working out a daily circumstance, engineering it to a finished result, that's really every day can be. If I mapped out my day, I can make it look with a whole bunch of art like a skyscraper build by how much information I can actually put down in there, distinguishing plays. How does this work? Over a massive information data bank, you can then refine that, find what are the main keys out of this, how different master structures are going to be beneficial in training models for other people, and not just other people, but by virtue mathematics, physics, psychology, other fields that are going to backbone this to better break it down, so everybody can kind of have a better understanding of what the same language is. That code, even though it works, I can use Chinese, I can use American, Native American, I can make symbols as long as they apply to any one variable that me and some other guy at least know in the battlefield, paper version of how we're doing it out here. So I wanted to throw that note in there. Hopefully it's not too much. Again, this is just everyday stuff. There's a lot going on, a lot of gravity all day. You're going real fast. You know, don't be afraid to get on that stick though, man. So catch you on the next one.